Cool. So we're going to talk about ArduPilot Lua Scripting. This will be kind of round 3 of this talk, as we keep talking about this every year. But excitingly, it's actually here. We can do useful things with it now. The previous years were kind of a, here's a theoretical one, and then it was a, hey, we've started working on it, but you can't really do anything with it yet. And as Trish said, people are doing really cool things with it. And it's actually, the rate at which that's going is kind of speeding up really nicely. And it's kind of fun to watch people just take this and go off with it. And then this has also driven a lot of other features, like the AP vehicle stuff Tridge alluded to. A large reason for doing this was actually because it enabled scripting to start doing interesting things with the vehicle. And scripting's also been the driver for why we added map-ftp in the first place. And then finally, as always, it's not Python. And I always consider that a large win. With this whole talk, before I go any further, I just want to say that, interrupt freely with questions. You can jump on the audio as well, because this is going to be pretty much driven by people's questions as we go on from here and some demos. So things that have happened since last year, we've added a ton of bindings. So you can currently look at like AHARs, the Army library, batteries, the GPS, math library, notify, rangefinder, terrain, control relays, talk to the GCS, the vehicle, serial LEDs, servo outputs, RC channels, serial, talk to UARTs directly, barrows, ESD telemetry, parameters, RPMs, buttons, and there's more PRs pending. And as you look, this keeps expanding what you can do with scripting. And I want to give a special call out kind of to Peter Hall here, who keeps adding a lot of these libraries and driving that forward. We support map-ftp, and this is really critical for scripting outside of the cool stuff Tridge is talking about with the param downloads or the thread status stuff. This is really nice because now you're working with your scripts. You can edit and upload without having to pull the SD card out of the vehicle. And this was incredibly painful because you have to go over, pop out the SD card, which is usually buried deep in the vehicle. Put it in your computer, put the file on it, put it back, don't lose it, make sure it's seated, then power cycle everything. We've got the REPL, which we're going to talk about in a little bit, but I'm pretty excited. I kind of wish we had done this a lot earlier. We can send and receive Mavlink messages from scripts now. It's PR, but that'll be in soon. The ROMFS stuff, and then we have a lot more documentation than we used to do. Unfortunately, about 6 months ago, the documentation was perfectly up to date, and since then it has lagged behind again a bunch. So we'll have to come back around and hit that up for some more improvements. So talking about FTP, I think we all know the obvious stuff now where it can read and write to the SD card. You can edit your scripts without pulling the card out. The ROMFS stuff is pending to run scripts from that, but it's going to be merged probably within the next day or so. And I could do a quick demo of what this looks like using Mission Planner instead of the map proxy client, but unless people want to see that, we can just jump over that. So quick straw poll, anybody?
Let's see it.
Demos are always good.
So let's come over to, just grabbing the right Mission Planner instance here. So you should have a Mission Planner instance for me now. Did I pick the right window?
Yes.
So we're just connected. This is a cube orange, basically running master. And then I'll swap the screen sharing over to the FTP window. Once I find it in this list. Interesting. Zoom will not let me share the FTP pop-up from Mission Planner. Okay, well, if Zoom won't let me pick that window directly, that's going to be a slight limitation on doing a demo for FTP. So if you could see it, you'd have a little window here, but without that, we will just...
Can you just share the whole screen?
Yeah, share the whole screen, Michael.
You're not going to like it. Can anybody see the Mission Planner window?
Oh, that's great.
The big screen. Holy.
Is he actually flying an aircraft there at the same time?
All right, so we're gonna drop that because I can't share that directly with you, but it is just, it's inside that menu. As according to Randy, it's moved inside the config menu recently. But it is pretty straightforward. It gives you a file browser. It looks all like you'd expect it to, but using that, you can navigate in, make the folder for your scripts, and read and write from it. So the REPL, we'll do a demo with this, and this one actually, we will be able to show the Mission Planner window. So REPL stands for Read, Eval, Print, Loop. And it's kind of the core experience a lot of people are used with, like Python, for example, where you type Python and you can just test your commands. So what that's saying is it'll read whatever we type in, it'll evaluate it, it prints the result back to us, and it starts the process over again. And where this is really handy is you can test your code snippets directly on the controller. And it makes script development and testing much, much easier, which translates to faster development time. And then depending on what you're doing, you can actually debug something on the vehicle. So if you have a script that's doing something odd, you can test the different versions. Or if you want to control UART directly, you can actually manipulate it. So we will jump over back to a mission planner window. And we'll use real hardware for this demo. So if we connect, maybe if we connect. All right, this one we'll swap back to Siddle, because it appears that Wine does not like using real devices. Okay, so this is Siddle. You know, it's the standard Canberra field. If we go to Advanced Script REPL, we can hit Connect. So it'll say starting REPL while it's trying to launch it. And then REPL actually works on FTP as the underlying transport. So if I now type in, 1 + 2, wait a little bit, it comes back with the answer for us of 3. So that by itself is actually pretty boring. But where that starts to let you do interesting things is you can say that, like, we know we have an ahars function, we can ask it for something. So it's not a method. So you can get the role directly from the ArduPilot, or, home equals ahars get home. So what you can see is this lets you just start experimenting with what the vehicle methods are, how they work. Where you can really start to make this powerful is that you can actually take a function that you have, a multi-line thing, you can actually load it in. So we can actually define a new function here for us if we want to. So say function SQR takes a variable, which is called in, which is a terrible name. Which now mission planner is being really sluggish under Wine. Now we have a new function that we've arbitrarily defined. So, if we square 4, we get back a value of 16. So where this starts to become useful is you can actually test your code little bits and snippets in isolation, and then bring those in as you're happy with them. So we'll probably use this a little bit more later, but for now, I think that's sufficient. Any questions with the REPL?
So is that's executing all on the vehicle, right?
Yep.
Or in Siddle in this case.
Yeah, so mission planner is just basically it's reading and writing from a file pointer on the aircraft. The vehicle actually executes the code and then prints the result into that file. So you're seeing the actual vehicle state.
So are you looking at a file that's growing? Is that what you're viewing in there on that terminal?
Yeah, there's 2 files that are existing on the SD card right now. There's an input and output file. So mission planner just keeps reading the newest things from the last bytes it read on the output file, and new commands just get appended to the end of the input file. So it's just your standard in and out devices as files.
Okay, so it's like rsync style where you're just getting the diff. You're not getting the whole file every time, or
Correct.
are you? Okay.
I mean, it really depends on your GCS implementation, but yeah, you should just be starting downloading partway through because you knew what the first part of the file was.
So I guess you'd run it. I was just sort of trying to clarify how long that file hangs around for. So say you defined your foo function or whatever. Obviously, if you rebooted your ArduPilot, the foo function would disappear.
Yep.
But if you try to redefine foo again, it would probably come up with some kind of error, right? And
no, you could actually define over top of itself because it's the same as if you defined foo twice inside the actual Lua script. Your second one would just replace the first definition.
Okay, cool, thanks.
And this is still its own sandbox environment. So anything you define in this function is only inside this. It's like it's its own script. So it doesn't interfere with any of your other scripts.
So this script is a file, but only in the RAM sense. There is no flash storage of this.
Correct. Yeah, and if you start a new REPL session, it just deletes everything that was on the file. So the file is really just a temporary scratch space for us.
What does REPL stand for? Read,
eval, print, loop.
Right.
So
okay.
you read the input from the user, evaluate it, you print the result back to them, and then you loop around and start the process again.
So this is all just specific to this REPL for debugging and experimenting, where you could actually just write the whole script that you figure out and then just dump it into your bake it in and have it available, right?
Yeah, exactly. So that definitely works. The main advantage of doing something with the REPL is if you had your iteration loop, if you don't know what the script is, right? So if I write something and there's a compile error, I put that onto the vehicle, I restart the vehicle, it does the initial bit of boot process, then it runs the script, then it prints the error at me. And then if I edit it and upload the new file, then restart it again, basically you're just left with a really long iteration cycle. Whereas with the REPL, if you had the helper function that you're trying to test the logic of or fix an error in, you can just paste that whole function back into the REPL, feed it the appropriate inputs, see if it worked or not, and then tweak it there without having to restart the vehicle every time.
And you can do multiple files through this REPL, or is REPL just like one file?
It's just reading whatever you type into it. So yeah,
okay.
It's essentially a single file.
Yeah, I'm just picturing the demo that you weren't able to show on here was you had that extra window that popped up to show the multiple FTP files that you could read and write to it. And is that SD card or is that all just flash?
That's all SD card.
Okay. So how does it work when there's files in flash and an SD card?
So the REPL is its own. It's just essentially everything on the SD card is just used as a scratch buffer, essentially. So everything on the SD card is just being loaded at once and then run. And everything from ROMFS is loaded at once and run. So at the start of the thing, we basically load all the scripts independently, give them all their own sandbox, and launch them. If you do the REPL, we say, hey, we're going to pause all of the running scripts for a moment while we do this special thing. And then we just read from the file, input and output descriptors.
I see. Okay.
Is that possible to use mav-ftp to transfer another Lua script and importing and use it in the loop?
So you can definitely upload a new file while you're doing that. Currently, we don't support the require keyword, which is to bring that in. That is on the roadmap, and it's something that Peter Hall would really like to see us bring in, and he's not wrong. It gives us a lot of new features.
No, nice. I'm not talking about the Lua rocks or something very complicated. It's just a single file. Okay.
Yeah, so there's a keyword in Lua of require, and that's used to actually import another file off the card. And we don't currently support that, but we should be adding support for that in the somewhat near future.
Okay, sure.
Okay, so moving forward slightly, one of the other things we've done and have as a PR at the moment is mavlink support. So you can actually have a script that registers to either receive a specific mavlink message and then decode it, or you can actually also send messages back out from the ArduPilot. So this is actually pretty exciting because this gives you a lot of flexibility in what you can do with the vehicle now. You can communicate arbitrary data to or from a ground control station. But it also means you can add new capabilities you didn't have before. So you could actually send a new command up. You could target it up towards the vehicle and maybe give it a different system ID or target ID so ArduPilot won't knack it, but the script can still see it. And the script can be responsible for assigned ACK or knack and take an appropriate action from there. So where this starts to get you interesting things is you could actually control, for example, you could be using scripting to do LED control. And you could actually run your light show where you sent custom mavlink commands that said, hey, we're going to move on to this other light command now. Start this part of the light sequence. And this gives you external gating of what you're doing from a GCS usefully. And again, you can do this without having to modify the ArduPilot code, which is quite nice. This is pending as a PR. It's just waiting for a little bit of final cleanup for me on some rate limiting stuff. This will probably come in next week. Might be a little bit slower, but it should be in pretty soon. And I'm pretty excited for what that lets you do with the script. So Tridge mentioned ROMFS, and I'm really not going to spend too much time here. The key thing I really want to emphasize with ROMFS is that as a commercial user, or if you have a script that is highly essential, so say you did a failsafe with your script, if you're running it from ROMFS, now you can know that the script is always there. So a problem that you can run into is that if the SD card's missing or somebody reformatted it, you lost your script that had your essential behavior. Once you put the script in ROMFS, now you know that every time you boot the vehicle, it's there. So if I've added, say, a fence failsafe of some kind that's specific to my vehicle, if it's in ROMFS, it will be running every time I boot the vehicle, regardless of what the status of the SD card is. And again, that'll be in pretty soon. So a couple of examples. A lot of these examples are actually in the ArduPilot repo already inside the scripts folder. There's a set of example files. So a couple of these that are worth noting in the failsafe section is there's some examples for plain code of looking at the current wind and how far you're from home, and then triggering a RTL early based on battery consumption and how long you think it'll take to get you to the landing sequence with an appropriate buffer. We've talked about that one a lot. Another one that came in is Tridge did some effort recently using vibration analysis in the EFI library to actually see what the status of your forward motor was on a plane. So you could actually trigger a failsafe and adjust parameters appropriately so that when you lose a gas engine, for example, the aircraft could actually return safely. There's a PR from Buzz at the moment, which allows you to start tweaking missions, and you can actually read and write all the mission items from the mission directly. So that's actually quite interesting because now you can actually do really specific validation of your mission, or you could launch the aircraft. You could have a file on the SD card that was like a polygon of area of interest. The aircraft could take off. It could, do a loiter because it can set the flight mode, can estimate the wind, take the wind estimate from the AHARS, and you could actually generate entire mapping mission on the fly on the aircraft. That's correct based on the wind and the other parameters of the mission you wanted to do. So this is starting to let you really do kind of advanced fancy mission planning that you'd like to do and you can do right now from a GCS. But the problem with the GCS link is you keep getting really stuck on what happens if the radio drops out and the ability to make it go smoothly. Whereas once you're doing this on the vehicle, you have a lot of reliability with it. And then LED controls. So this has been coming up a lot. There's a lot of things you can do with LEDs. There are now examples of playing Pong on an LED panel. Scroll and mirror keys with text that you can read. You can read the battery status, show the roll indicators, light shows. This one really kind of keeps going on. And the key point of this is Peter Hall really likes blinky bits. That seems to be the underpinning part of this. To jump back to Bruno's question there, it's anything with 2 megs of flash we currently build Lua Scripting into. So we're going to jump really quickly. I'll pull it up here, but the Zoom doesn't do terribly well with video. So if you take a quick peek at that video, this is a demo of running 97 Profi LEDs and 48 NeoPixel LEDs on the same flight controller. And this is from Peter Hall. It's quite a long video because he demos a lot of things, but there's a couple of highlights that I think are kind of interesting ones. So you should be seeing the video now, and this is actually a HUD indicator, so you can actually see the artificial horizon trying to be drawn over the real horizon. It's of course wonderful. A little limited. It's limited by the panel resolution, but it's actually still really cool that it works.
Yeah.
As we jump through, he's actually playing Pong here. I don't think I have audio coming through on this, but he actually even has the buzzer playing beeps and boops as it hits the paddles or misses. You can see the score is counting up on the NeoPixels on the arms, and he's actually using the sticks to control the paddles because the aircraft is actually in brake mode. So what you're starting to see here is that the flexibilities on this get really aggressive. The next step of where he could go from this script is, you could actually stick multiple vehicles together, use the Mavlink to coordinate where they are, and they could actually play a game of Pong where you have, one quadcopter is the ball going around, and the other 2 are paddles, and you can do LED strips to give them their height. But based on all the goal position stuff and using the Mavlink stream, you could actually coordinate games like Pong if you wanted to in the sky.
I gotta say that this Pong is epic.
It is incredible.
I recommend watching the video directly because I'm sure it didn't come through very well here, and we're not going to stick with this because this is quite a 7-minute long video. There's also some examples in here of he's scrolling text across the display, and then he's using the knobs to actually speed this up. And I think he'll probably be pushing this video around a little bit more further in the near future.
That is incredible.
So I think Peter gets a lot of credit for showing nice demos of this. And then finally, vehicle control. So again, there's a video. I put a link to the slides in the Skype chat for this. But if you look in the presenter notes on this one, there's a link to an example of doing delivery interactions where he's controlling the vehicle state and the buttons to toggle the aircraft to arm and disarm. And then there's been a recent video, and you can find the video up from Randy, and there's a link in it as well. But that shows using the vehicle targets on copter to actually do a spiral up through the air, where scripting is controlling where the aircraft is trying to go dynamically. So this is starting to really enable a lot of interesting behaviors. I do recommend going through those videos, and Randy's is also good because it shows you how to get started with scripting again. So now we're going to go a little bit sideways, and it's probably get a little interesting. It's most of the features I have with scripting directly. If there's any questions, we should talk about those first. But failing that, I think something that might be useful for people is if we actually went through an example of writing a script that did something. So I'm absolutely open to ideas off the floor, but other things that have come to mind that we could potentially do. Plane doesn't support a high altitude or circular fence. That's just based on home, so we could implement that. Arming check to ensure your sticks are neutral, but I will actually probably be doing that as a core arming check that doesn't require scripting in the near future anyway, so I don't really recommend that one. Arming checks for mission standardization. So we have some arming checks right now that check that, do you have a takeoff? But you can do the example of a scripting one using Buzz's PR that says, hey, do I have a takeoff, and is the height appropriate for my vehicle? Is it trying to take off too high for a quad plane, for example? And then the other one I've thought of is we could try sending some Mavlink data down to the GCS or parsing it, but I haven't really prepared anything specific. So if anybody has questions they want to look at instead, we should bring those up and we can implement those as an example. To jump to James's question real quick from the chat, this is actually based on Lua 5.3. We've just disabled some functions and libraries we're not using, but this isn't using any of the Lua JIT. And the other key point with this is that this is Lua 5.3, so you don't have to use the bit32 library like you might be used to on some older Lua implementations. I'm just mentioning that because that's come up as support questions a couple times of where is the bit32 library. Does anybody have a preference on where we jump to from here?
I'd like to see sending Mavlink data.
Sure. So Mavlink is an interesting one. So one of the things for the Mavlink stuff to work is you actually have to know how to send the Mavlink messages. So to do that, we actually have a PyMavlink PR that actually added the support to the Python generator to generate the appropriate file for us. So what we'll do now is we will jump the share over to a terminal window real quick. Oh, there's a bunch of terminal windows here without previews. Let's see. Do you have a relatively big terminal window that you can kind of read that says it's in the ArduPilot scripts folder?
Yep.
Okay, so let's go up 2 folders. So we're in PyMavlink in the wrong one, so let me just check out. Actually, have we merged the PyMavlink stuff? Does anybody remember?
I don't think so. Just having a look now.
How about I merge this for you and you merge some stuff for me?
No, we have not. So we'll switch to that branch. I'm just going to ignore that, Tom. So ArduPilot Lua. Okay, and then so if we,
it's now merged.
Excellent. Okay. So we are going to the generator, and no, we can't go to the generator. Got to go to tools. I do struggle with PyMavlink, so feel free to comment on that. I no longer have the PyMavlink history command I use. So we're going to feel our way through this real quick. So generator, mavgen.py. And this is the problem I'm trying to remember again. Tridge, which directory do you have to be in?
Well, Mavgen can run from any directory
No,
unless you've got a dependence from the Lua.
If you want to use, if you want to use your local install, it has to be from the right path. That's what I'm trying to remember.
Oh, I assumed you were going to install just with Python set up to Py. I could actually do a new release right now if you like.
Well, that sounds dangerous. right, so I think it's actually this one inside tools works. All right, so we're going to say language is going to be Lua. It's key to note that there's a Lua and a W Lua. W Lua is the Wireshark Lua implementation. So that will not run on the flight controller for you correctly. We're going to put our output to, and we'll put it in this folder for now. So out.lua.
Speaking of multiple versions, James O'Shaughnessy was asking if it's Lua or LuaJIT.
Yeah, we jumped to that. It's actually Lua 5.3, not LuaJIT.
Okay.
So link message definitions 1.0. Okay, so the command line for that again is basically just the output file. So I'm calling it just out.lua, and then you just at the end you give the file to run from. So this now gives us this large file. So basically what you see at the top, and we'll turn off the line numbers for people. So we have a decode message for ourselves, a decode, encode, and then there's this large table down here. Each one of these tables tells us how to decode a specific Mathlink message. So this is now the entire XML contents. Your only concern with this is that as you load each one of these things into the table, you're going to use more memory. We don't really care about using all that much memory. So what message do we think we want to play with? I just haven't had a... How about let's do command long. All right, so we're going to delete everything below this.
How about experiment where we try and arm and see if we get the result if we armed or not?
Well, we can just arm directly in scripting.
Oh, I think that's true. How about commanding a gimbal?
Well, I don't have a useful gimbal for us to play with. That's the main limit there.
Can you, so the Mavlink only ever goes out to a ground station link, doesn't it? Is there any way to inject the Mavlink to the ArduPilot?
There isn't right now. We have talked a little bit about that because it actually would be pretty interesting. But I have not currently added that support. Because then you could do everything that you can normally do through the Mavlink interface. And we could just dump it into the buffer.
Yeah, just less efficient.
Yeah, like you could trigger calibration or something weird like that from the Lua script.
Well, how about sending guided commands?
Well, again, you can actually do guided directly.
Yeah. No, but yeah, but it's at least showing that you're commanding something and showing it's executing and whatnot.
So what we can do here is we can send a command long from the GCS up to the aircraft.
Well, hold on. How about this? How about this commands a different aircraft, like a different message ID?
Well, so we could actually emit the command long from the aircraft and send it to another aircraft. That will just work. But I don't have a good setup to replicate that in CITL. So my current thought is to send a command long up from a GCS to the aircraft, and we'll have the aircraft print something out with it and then send it back. So let's take this. So this is our script. Basically, I've just deleted everything else except for this one message because this is the only one I really care about. And we're going to use this as the basis of our new script to do something cool. So most ArduPilot scripts basically boil down to an update function that we're going to call periodically to handle something. So we'll define just a normal function called update. Doesn't take any arguments. And we'll return itself, keep looping. And let's say we want to run this at 2 hertz. So that's going to be 500 millisecond delays. So things we want to do at the beginning is we can come in here and we're going to want to tell it to register for a Mavlink command. So if we want to actually parse an incoming command, we need to actually say that, hey, this specific Mavlink command is something I care about. So if we come over here, and I should also check out the correct ArduPilot folder for us. We'll not be able to use this correctly. Okay, so what we're going to do is we're going to call register message ID. So what this is saying is we're going to register for the Mavlink message ID of 76. So 76 being our command long, so it says, hey, this script cares about getting a copy of this message. So inside the loop here, we can then say, so we're going to get our new message by saying mavlink receive. So this would say, if there's any mavlink message pending, we're going to stuff it off into this buffer. So if message, and then we can come up and call our encode function, which is actually inside this. The key point with the encode, or the, sorry, we're going to call it decode. So decode needs two arguments. It needs the message and then the table that describes how to decode the messages. So change that to decode instead of encode. And what decode will actually return to you is it just returns a new Lua table that's the fully decoded result. So let's say that we can actually just decode it directly, I believe, but we'll keep doing it this pattern. And then we care about just seeing the values at the moment, just to make sure that we're actually receiving the command. So there's a couple things we could do. Is first, we could actually write this whole script out and we could send it to the GCS as send text, and that's the equivalent to our printf debugging. But in a lot of ways, that's kind of boring, mostly because it's just that long iteration time as I talked about. I think what we'll actually do is we will update Citadel again. And then if we come over to our mission planner, we can actually start testing these functions before we go any further. So I'm going to restart mission planner here. Change which screen we are sharing. Double check that Citadel actually built. Nope, Citadel's still compiling. Sorry, I had the wrong branch checked out, so now we're just waiting on the recompile time. And then what command do we want to use? What's an easy, useful command?
Like a do set servo or something like that, maybe.
Yeah, you can do that from the mission planner UI easily, right?
Yeah, there's a servo tab on the data screen down at the bottom.
So before we continue on with that, it's not compiled. So what we can do now is if we come back to our setup, REPL connect. So what I'm going to do here is I'm going to cut in all those core decode functions that we cared about. So we'll bring in this long list of functions. So now the mission planner REPL window, if you can see it down here, this is actually a bug in the beta version, but basically it's ate everything I gave it. Is that still sticking for everybody, or is it people now lost the view of the screen?
I can
There,
still
it's
see
a
it.
little hard to read.
It's a bit small, so sort of black on gray isn't great on this sort of display.
Yeah, here, we'll try this. So the problem is I have two instances of mission planner running here, and they're both under Linux.
It is readable, it's just not quite as clear as it could be.
Yeah, but it's doing a scroll thing, which is going to cause a problem. All right, so you should still have another view of Mission Planner. So I will say this one is running under Mono. The Mission Planner REPL stuff under Mono works, but you do get this little artifact where it prints an extra line periodically. And that should be. So something to note here is I typed in this command, mavlink.register message ID 76. That was incorrect because I was trying to do a table lookup. It actually should have been mavlink semicolon register. So it was easy there to actually just make that change and then test it. So now basically this REPL window is looking for anything with message ID of 76 to be coming to it. So if we said foo equals mavlink receive, this would actually try and pull an incoming message out. If I can type. There you go. I just apparently can't spell correctly. So foo right now should actually be nil. Slightly actually confused what's happening. So let's bear with me just a moment. Oh, because trying to call that. Okay, yep. So right now there's nothing there. So if we then come over here, where is the servo relay? And these are the commands, Randy, that send the servo relay?
Yeah, I think so. That might be a problem if Mission Planner is going to disconnect us when we do that.
And it will have lost that state?
So the REPL situation would be continuing unless it sent the disconnect command. However, that's going to be hard to show with the REPL if it's doing that. So we will probably have to actually switch to using the script directly. So in that case, let's just disconnect the Mission Planner one. We'll pull the screen share back over to our script.
I guess you could also use maybe mavproxy or something.
Oh yeah, no, Peter's right. I keep forgetting this. You can pop out the REPL tab. But either way, I think we'll just stick with that. Just to prove that this is working, we'll put in a send text. Send it down as high priority, that's fine. We will move this script into our scripts directory. So we go back up into ArduPilot scripts. And we were editing a file that was in the PyMath directory, so we're just going to copy that back over. So now inside our scripts directory, we have two things. I don't need that RGB test, so we'll just remove that real quick. The other key thing here is you notice I actually have a script skipped folder inside the scripts. Anything that doesn't end in Lua will just be ignored. So we can have our subfolder of things that we don't care about. So then we're going to relaunch our REPL. And we'll swap the view back over to, actually we're going to use, because I will stub my toe with it less. All right, so we have GCS window that should be up for you. So we can see our scripting messages come down here if we have any errors with that. So no scripts run, so we've made a mistake. So we'll come back over here.
Live coding is hard.
It's pretty bad. I don't tend to do it. I'm slightly regretting it, if I'm being honest.
We can move on. It's fine. I was actually, main thing I wanted to see was I understand the Mavlink stuff a lot better now. And I know it was a difficult example to pick on. So it's
yeah, it's one of the harder ones. I probably shouldn't have just put it in the list.
Yeah, no, that's fine.
Don't worry, Michael. It's only 60 people that are watching over your shoulder.
Pretty sure, I think it's more.
Well, plus all the millions on YouTube.
Yep.
Don't be nervous.
4 billion.
You know, if there are billions, I think they have better things to do.
No, couldn't be.
Okay, so register message ID expected 1 argument's got 2.
Do you want to sum up and we can just
we can move on with that later.
I think so.
So if we come back over here, the quick roadmap, basically extend the vehicle control a lot further. There's a couple PRs for this at the moment, but the recent stuff Randy put in for like the vehicle attitude targets are mostly for copter and rover. So plane should gather a few more of those. I think we'll see people keep wanting to do more with this. Pull the documentation back up to date. It's just rather behind at the moment. Again, a lot of those libraries that we've added, we haven't put into the docs yet. So we need to bring those forward as well as more examples. Bring in support for require statements. So this does the things people were asking about earlier where you said, hey, I want to bring in this Lua file that already does something and pull it in. It'll also actually probably help a lot with the Mavlink stuff because we might be able to put the message definitions already on disk for you in the build, depending on how much space they take. And then it'd be much easier to pull in the messages you cared about sending specifically. And then finally, there's some work on the tooling. So the generator that we talked about in previous years has been essential to letting other people work on adding new things to the bindings easily. But getting it into the WAF build automatically is going to be one of the nice important improvements. And then kind of taking it a little bit further with some cleanups that we have pending. Again, there's PR for the WAF stuff, and I'm pretty excited. But I also really don't understand WAF, so I'll be using a little bit of heavy lifting help from Tridge on that one.
That's from a GSOC student, and he's planning to do a whole lot more WAF stuff as part of the GSOC project. It's really nice.
Excellent, because WAF is a interesting implementation at the moment. And then finally, just to say that, looking forward, 4.1 should be really exciting. I know we have some scripting stuff out in 4.0, but there are a lot of limitations on what it can do. There's a couple methods on it that are broken, like set mode, for example, should not be used in 4.0. But 4.1 has a lot of stuff that we're looking at today or talking about, and that'll be really exciting for letting people just run with this. Which brings us to the final questions point. But I think we've probably kind of ad hoc addressed them and running a little bit late.
Well, that was absolutely fantastic. And the progress you've made on scripting the last year is just astounding. And it's just an amazing feature now, so flexible. Any final questions?
No, I just have a comment. Just from like a developer and support point of view. One of the great things about scripting is that it allows people to prototype stuff easily, so it stops getting stuck on the core developers. Like for example, there was this big thread about can we make an RTL that can get home without a GPS? And there's so many comments people want and stuff, and I said reply saying that's really difficult. I don't even know if that's possible. Having scripting here allows much wider audience of people to go in there and try stuff, and then they can find it for themselves. Whether it works or not, and it doesn't just fall on me or one of the other core devs. So I think it's just super awesome. Thanks.
Yeah, incredibly useful. All right, with no more questions, I think a round of applause for Michael. Excellent. All right,
I'll send you a script with a looping clap.